Okay, what happens if we try to do something like x plus 2 cubed? So we're taking it up 1 in the coefficient. And you might think, okay, well, we had rules for sum squared, we had rules for a difference squared, we had rules for a sum times a difference, so we had rules for all of those. So can we make a rule here? Absolutely. Do we need a rule here to solve it? Absolutely not. What does this mean when I say I take x plus 2 to the third power? It means x plus 2 times x plus 2 times x plus 2. Don't be afraid to go back to the definition of exponent. So what I could do is I could do these 2 times this or these 2 times that. It doesn't matter. Let's multiply these two together. I get x squared plus 4x plus 4. How did I get that so fast? Well, I'm taking the first terms, but remember, I already know that a plus b squared is a squared plus 2ab plus b squared. So I take the first thing squared, which is x squared, and then I take ab, but I multiply by 2, so I get 2 times 2x. 2 times 2x is 4x. And then b squared, well, 2 times 2 is 4. So that's how I was able to do that quickly. And now, in order to do this, well, I'm just going to distribute this all out. And I could even write it out as an extra step. I could write it like this. So I have this times x, and I have this times 2. Now, what do I get? I get x cubed plus 4x squared. You might think, oh, this is long. Yeah, it's long. None of the steps are too hard, so we just have to be careful. There's nothing for us to be too upset about. So, and boom, we get our answer. Was this the only way to get our answer? Absolutely not. At this point, I could have just taken each of these times these two, instead of rewriting it using the distributive law. Or I could have taken each of these times each of these 3 without rewriting this using the distributive law. Or I could have right here multiplied these 2 on the right first. That would have been fine as well. Or there's another way. Let's think about this law here and think about what would happen if we apply it to a cube. So let's say we have anything a and any b cubed. So this is a plus b times a plus b times a plus b, which I could also write as a plus b squared times a plus b. This I know is this. And then I just multiply this all out. And I could do it all in one step. Let's maybe try that. Let's multiply the a times all of these and the b times all of these without rewriting it using the distributive law. What do I get? I get a times a squared, a times 2ab, a times b squared, b times a squared, b times 2ab, and b times b squared. Okay, do we have anything at all we can combine? Any way to simplify this at all? Is there any way we could possibly think of to simplify this? Let's look at that. Here I have an a times b squared, and here I have 2a times b squared. So if I have 1 apple and 2 apples and I put them together, I'm going to get 3. And what about this and this? These are both a squared b's. So I have 1 a squared b here, and I have 2 a squared b's. I'm going to get 3 a squared b's. So I get this. And this is equal to a plus b cubed. Now, what you don't need to know right now, but you might ask, is okay, you did this for a plus b squared, and now you've done it for a plus b cubed. Is there a way to do this for a plus b to the 4, a plus b to the 5, and higher powers? And the answer is yes, and the rule is not too bad. And we will get to that at a later point. There's a nice way to determine what these numbers are that we need to put. But we are going to get all the different combinations of a's and b's so that the exponents add up to 3. Why don't we want to do that now? Well, let's use our formula to make sure that we get the same answer that we did last time. So let's use this formula to find x plus 2 cubed. And the answer to this is going to be, okay, well, how do I do it? Well, a is going to be my x and b is going to be my 2, and I'm going to plug this into the formula, and what do I get? I get x cubed plus 3x squared times 2 plus 3x times 2 squared, which I'll just write that as 4 right off the bat, and then plus 8 because the last thing is going to be 2 cubed. And I can rewrite this as x cubed plus 6x squared plus 12x plus 8. And lo and behold, what did we have last time? The same thing. So it doesn't really matter which method we use. You might say, hey, this formula up here, it's a little tricky to memorize. Maybe, maybe not. That's up to how much you want to remember. But it does come up now and then. There's a similar one that I'm just going to write down for you, which is that a minus b cubed equals a cubed minus 3a squared b plus 3ab squared minus b cubed. And I say it's similar, but it's actually just a consequence of what we already saw. So we know this is the case. So what would happen if I just take a plus negative b cubed, which is the same thing as this? I can use this formula to get this formula. Because if I plug this into here, what do I have? Well, I have 3a squared negative b plus 3ab squared. Why did I get rid of the negative? Well, I know I'm going to have negative b times negative b, so I didn't even bother. Do I need the parentheses? No, I don't even need that. And then here, I have negative b cubed. Well, that's actually going to be negative b cubed because negative times a negative times a negative is a negative. So this gives me a cubed minus 3a squared b plus 3ab squared minus b cubed. So that's the same formula that I have on this first line here. This formula comes directly as a consequence of this formula here. So we have both formulas for cubing a sum or a difference when we have a binomial, whether it's a binomial sum or whether it's a binomial difference. And keep in mind that differences are actually all sums in disguise. So there really aren't two formulas. There's just one formula. And that's it for that.